All right, guys, welcome to another KevCAM night class tonight. Tonight we will be covering HSS projection. And tonight have Terrence helping out with any questions or concerns. And Terrence, are you there?
Yep, good afternoon, good afternoon. Good evening, everybody.
Which was afternoon still. No, for those of you guys that are new, these night classes are solely dedicated for you guys for a learning experience. So if you guys do have questions, we use GoToWebinar as the platform to teach you guys. What's that? Am I breaking up? Uh-oh. Did I lose you guys?
Kev, we're not hearing you tonight.
Oh, man. Here, let me try something else. I'm running into some internet issues tonight, obviously. All right. Can you hear me now?
There, we got you back.
All right. Sorry about that, guys. All right. So what I was saying is we use GoToWebinar, and everybody is in mute only just to eliminate any background noise. So if you guys do have questions, definitely type those into the chat box for us, and Terrence will read them off to me, and we'll get those questions answered for you right away. I'd like to start off everyone with our topics, get all our topics from you guys. So like I said, shoot those over to me in email and we'll get those implemented in. And if you shoot us an idea, we'll give you a free hat and t-shirt. So, and for those of you guys that don't have my email address, let me, I just put it into the chat window for everybody that should have my email address in there. Also, every night class has been recorded in the past, and we were recording this one just to use it as a reference. If you guys want, you guys can go to YouTube and type in SolidCAM University, or you guys can, type in KevCAM, and it will pull up it. Lots of tips and tricks in here. I actually uploaded some live cuts just the other day. This one right here is actually pretty neat, doing a testing a Gouge diver tool with a 30-degree helix ramp angle. So pretty cool to check out there. But like I said, huge source of knowledge base right here for you guys. So there's tons of videos in here, and like I said, if there isn't one in here, we will add one in there for you or make a class out of it. So, and George, I think you sent me an idea on undercutting. So we do have a undercutting video right here on how to use HSS undercutting with a lollipop cutter, and just for finishing up those bottom side radiuses, or if you guys had a actual flange out kind of part right here like you can see. But definitely come here, check it out, and like I said, any ideas, I know George, you sent me a lot of them. Ronnie, you sent me some. Rick, you've sent me some too. Definitely send those over to me, and we'll definitely get those implemented in for you guys. So, all right, let's get the ball rolling here, and let's go over HSS projection. Pretty much a projection is basically kind of projecting onto a 3D surface is kind of what the projection is. Now, if you use, there's 4 different projections. We have user-defined, radial, spiral, and offset. The user-defined is basically you guys can draw a sketch on there, and it will project it on to the actual 3D curve. Radial we'll get into, and spiral we'll get into, and offset we'll get into towards the end here. But kind of came across something real interesting. And Greg Payton, I don't know if you guys have been, any of you guys worked with Greg, but he's one of our top AEs here, and he's kind of the one that's been pulling up these parts and making these parts for us for the teaching. And we kind of ran across something really kind of cool with the offset cutting that I didn't even know was there, and something that I don't, HSS projection is something I don't use very often. But we did come across something really neat, and kind of excited to show you guys that. So, okay, so let's get the ball rolling here and stop the jibber jabber, and let's get some toolpath going. So for this first one right here, basically what I want to do is do a projection down. So what I'm going to do first is I'm just going to do a parallel cuts linear, and let's get this surface, down to a finished surface here. So this is a little bit of a repeat, but we'll just go through it real quick here. And I'm going to grab my tool 2, which is a 1/4 inch ball end mill. Go to our toolpath parameters. Well, let's just see what we have, kind of like what we've done in the past. Get some toolpath on there. So I got some linking that I can kind of clean up here on the ends. So let's go to our links, and let's do follow surface, and let's just do a blend spline for these bottom ones here. Okay, beautiful. So we're looking good on our toolpath here, covering that surface entirely here. Now let's get a nice looking finish on there of, if I can click my mouse tonight, let's do a 10th thou. Okay, and let's just do a quick simulation. Okay, so now we have our very oddly contoured 3D part right here. And kind of picked this part just because it is so wavy. So what we're going to do now is project a sketch onto there. So let me go to my SolidWorks here, and let's see, I have a sketch in here. I've lost my sketch. See, could have sworn I had it on here. Well, no problem. So what we'll do here is we'll do a sketch above it. So we'll just go to our sketch, and let's just do let's do a square for right now. We'll do on this plane right here. And we'll get a top-down view, and let's just say we want to do this square right here. And let's go ahead and add some fillets in there. So let's just do a 30 thou. Okay. So we got our sketch on there. So what I'm going to do is I'm going to actually shoot that up. And I should have actually done that prior. So let me get that one going here, and we'll just do add a plane in here real quick. Well, actually, let's see if we can actually pull it off of here. So you'll see that that sketch is kind of buried down inside there, and to actually get that sketch to go on here is a little bit of work inside SolidWorks. So now what we can do is go to our SolidCAM here and do HSS. And now what we're going to do is do projection user defined. So what I'm going to do is grab my geometry. So my drive is the surface that I want to cut. And now my projection curve is what I want to project onto it. And it's almost, you know, you can kind of think of it as 3D engraving, kind of close to the same lines, but we're able to do it with projecting it on there. Okay, so one thing that you guys will want to take a peek at here is what you can do is you can do a max projection distance. So let's just say that you guys had multiple areas that had that projection, and you guys just wanted to touch on anything that was, you know, 5 thou of the projection. For this one, I'm really not sure the distance where it's at. So instead of doing a direction, a surface normal 2, what I'll do is go to Z-axis, and as soon as I pick Z-axis, this should actually gray out because anything in the Z-axis direction it's going to grab. And what it's going to do is just basically project that onto that surface. Now my drive surface offset is the same as before, so I'm just going to kind of do it as like we're engraving something here. So let's just do a minus 0.5 thou here. And let's go ahead and grab a smaller tool here. And everything is kind of set. Let's just do save and calculate. And it's not going to allow me to project it because I think I need to be above my surface there. So give me 1 second here, and what I'll do is come over here. Let's do edit part, and we'll do a plane right here. Go up just a little bit higher here. And now, if I do a sketch on that plane, actually we'll just do convert entities. Let's see if I can grab this. Oh, no, it's not going to let me grab it. And let's go ahead and round off those corners here. And go ahead and get out of there. Okay, so now we got that in there. Now, if we go to our geometry, and we'll grab that curve there. So there we go. Okay, so you can kind of see what's going on here is it's taking off that projection above, and it's projecting it down onto the surface. So this is just kind of one example I wanted to show you guys. And let's just do the toolpath here. Solid verify here. And you'll see that it's projecting that sketch right onto that 3D surface, going around any curvature that you guys have. And what I actually told it to do is to cut, down a -5 thou to actually cut into the material, so we can kind of get a reference of what's going on. And you guys can do this with anything. And where this actually kind of comes in handy is had a customer that wanted to do knurl on his part on a really contour 3D surface. And so what he did is he grabbed all those lines, and then we were able to create knurl on a completely 3D surface, which was done actually fairly easy and just by grabbing those sketches. So one nice feature about that right there is, like I said, it saves you the work of having to project that sketch right inside SolidWorks, and we can let SolidCAM take care of the projection of it. So, and now we know that it's cutting exactly where we want to be. And like I said, it's a couple nice features in there about it. But like I said, it kind of came in real handy with that particular customer when he was trying to do a knurl on a very oddball surface, kind of like this one as a wave. So, all right, guys, any questions with this particular part in doing projection here? All right. So let's go ahead and close out of here. And I'm going to go to this guy right here. Okay, so here's going to be another example of doing projection. And let me just get rid of these. Let me start fresh here. Okay, so let's go ahead and do let's say we just want to come in here and touch these corners off with the ball end mill. So we'll just do our HSS again, and we'll leave it on projection user defined. Now my geometry for this particular one is going to be the radius. And now my projection curve is going to be the actual bottom of the radius. Now you guys may be saying, we can just do this with profile, which is very true. But we're going to go to one more extent here and show you a little bit difference. So now we can grab our tool, and and I'm sure that you guys are saying, like I said, just use profile, in which we can, and it's going to work just fine. Let's just do a save and calculate, and you can see in here that we're just coming in here, coming around the corner, and get kind of motioned over here, and cleaning up that surface right there. So if we go to our solid verify, comes in and cleans up those corners real nice. Now, if we want to take this to the next step, you know, and where we couldn't use profile is if this was actually on like a 3D curve right here. So let's go ahead and just kind of open up that part real quick here. So you'll see right here, pretty much the same principle, but now you guys can see that we're actually kind of, you know, if we're looking at this part straight on, we have an angle going up. So to accommodate for that angle going up and then going over and coming across and having that full gouge detection is kind of where that user-defined kind of comes in handy for us. So like I said, what we'll do here is do another HSS and we'll do our user-defined. And our drive right here is going to be our radius again. And our projection curve is going to be our bottom line here. And we'll leave our drive set up there. Let's do our, well, we can leave our normal to surface. It really doesn't matter because we're staying within our 5 thou here. Let's grab our tool and let's just do save and calculate. So you can see right here, it's following along with that 3D curve. So the toolpath is completely going up at a taper there and then shooting across in X and then coming down in a taper in a YZ motion. Now if we want to clean it up a little bit, we can come over to our, because you'll see that we're kind of stopping right at the exact edge right there. So we can come in here and we can say use lead in and lead out and get a nice arc coming in and arc on off. And if we want to, we can come in here and do a solid verify. Arcing in, going up and around, and coming back down. So that's kind of where the user defined kind of comes into. You can put it into a couple different factors there, but you know, and there's, you guys can use you know, a contour 3D to achieve this inside your operations. If you guys went to, did the contour 3D here, but with that contour 3D, you don't have any gouge detection, any of the advanced features like that that you're kind of missing out on. So, any questions on this at all, guys?
Yeah, we actually do. Oops, I'm sorry. Mike was a little off there. Yeah, we actually do have a question from George.
Mr. Lauer, what you got? Let's see. In this case, wouldn't using 3D engraving be easier? Are you talking, let's see, he sent that, yeah, about a minute ago. Are you talking with this one right here, George? Well, let's just try it. I guess I've never thought about using 3D engraving to do a chamfer, but we will definitely take a peek. All right, so we'll do 3D engraving. Got our surface. All right, and we'll grab that same cutter. Levels. I'll just kind of leave everything set right here because I really don't want to engrave into my part, so I'll just leave that at 0. Technology. Let's just take a peek here. Yeah, we need to switch this to left. Oh, actually. actually what I need to do is do center, I think. And let's go ahead and see what we have here. So it's popping up on that end. And I'm guessing because it's not really totally meant for doing the radius in there. Let's see what if we got anything we can do to keep that down. It's following along there, so it should be going. Just look real quick. Yeah, we don't have anything I can kind of change over here. Let's just try doing left and see what our toolpath looks like. So that looks good there. So I guess what we could do is, I'm just trying to think here to get that to clean up the way we're trying to follow it here, is we need to bump that over. I can't do a side offset currently. So George, I guess to answer your question, looks like we're better off using HSS, but I definitely see what you're talking about here, where we should be able to, let's go back to left here. Can I modify? No, can't modify anything in there to shift that over. And that's very curious on why it would be hopping up right there towards the end. And I really don't have an answer right offhand, George, on why we're hopping up there, but I see where you're coming from. But I guess to kind of answer the question, you guys will see we don't have any gouge check. We can't do, if we get into something real complex here, if you want to guys do a check surfaces and do your drive surfaces with a gouge check or your tool and holder collision, keeping your links down, and you'll see right here, I mean, we're picking the exact same geometry from one to the other, but you'll see one staying down, working like it's how it's supposed to, and then the other one's kind of hopping up in the centers there. So, but yeah.
Hold on a sec, Kev. Yeah, we have a comment there from Mr. Kidder.
Toolpath tolerance. So I'm at 5/10. Ronnie says try a 10th. No, looks like, oh, yeah, we need to keep that on center there. Let's just try doing an even tighter tolerance here. Yeah, we're still hopping up. Trying to see what would be causing here. And that one's not even hitting that back. Something with that back edge is kind of going goofy with us, and it could just be the surface there, since we kind of created a 3D area. But let's see, maybe worried about, yeah, it could be definitely, Randy's saying that could be worried about touching the back wall here and getting too much of a gouge in there, so that's why it could be hopping up. But another reason to use HSS projection. I know, guys, it's the projection side of things is something that I don't use hardly ever, but for scenarios just like this, it would be good. Now, if we want to, what we could also try, since we're kind of going along that same lines, is if we did a contour 3D. And we'll grab that same cutter. Levels, center. So we can get this done with Contour 3D. And the only thing is we don't have, like I said before, we don't have the additional features in there. So definitely we'll do it if we just do a simulation here. And it looks like we're almost gouging. Yeah, with Contour 3D, we're definitely gouging into that wall, and I'm guessing that's why the 3D engraving wasn't working either. So, yeah, and thanks for pointing that out, Ronnie. But So it looks like our only option for that one, it would be to use the HSS projection. But any other questions with this part? And we'll actually hop into the offset one here. Okay. And let's get into recent parts and offset. Okay. So this is kind of one that I came, well, I shouldn't say I came up, Greg Payton came across, and it was quite interesting. I was a little lost at first, but hopefully I can kind of convey this to you guys and make sense. And definitely, if this one doesn't make sense, please let me know. So first thing what I'm going to do is I want to get this area cut out. You'll see I did a 3D eye machining first, and I'll come do our HSS, and I'll just do parallel to curve, geometry, grab my geometry that I'm looking for here. All right, got all our surfaces that we want to cut. Grab that top curve, and we'll just use our ball end mill here. Toolpath parameter, can't talk, toolpath parameters. I'm going to do 10th step down, and we'll do a spiral. Okay, so we got a good finish pass on there. Now, if we play this through here, get the updated stock here from that 3D eye machining. I must have a really tight tolerance going on right now. Let me just pause this for a second. Yeah. Get out of here and come back in here. Okay, so everything's been cleaned up with that parallel to curve there. So now what I'm going to be doing is if I go to my machine stock, you'll see that I still have material in these corners here. So this is kind of where the offset one's going to come in handy here. So what I'm going to do here is do our HSS, and we'll do our projection, and we'll do an offset. Now my drive is going to be the flat bottom that I want to cut, and my projection curve is actually going to be the bottom of the floor here. And let's wrap that around here. And now what I can do is I can say, you know, do I want to go left or right? So we'll just go right now, and I'm going to say number of cuts to the right. Let's do 10. And let's grab a cutter here. And we can set our step over to, let's just do a 10th step over to match what we had before. And I have my chain going the opposite way, so I'll just switch this over to left. And we'll do 10 this way. There we go. So now, if we go into simulate here, solid verify, and we're cleaning up those corners now, those little nubs that were sticking up. But let's just say we don't want to machine that entire surface. We're kind of wasting time cutting along there. So what I can actually do now is come to my roughing and more here, do the stock definition, avoid air cuts or anything that was already cut. And let's do save and calculate here. And it should be jumping up everywhere, excuse me, except for those corners. Okay, so you'll see now we're just coming in there and just whittling out those corners, which would be kind of a nice feature to have in there just to kind of clean up those corners with HSS. So kind of, I don't know, I thought it was kind of cool to see it. Now, if you guys didn't want to come all the way up and retract, you know, what we could do is go to our link here and we can just do safety so we're not coming up so high. And now we're just, like I said, just nibbling away at those corners there. And, you know, if you think of offset cutting as the same thing as like I'm trying to think in profile, clear offset. We're just kind of offsetting the geometry over one way or the other. And then this one we just took a little bit farther and we're just cleaning up those corners there. So kind of cool. Like I said, something I really even come across, or Greg kind of came across, and that was kind of neat. So I figured to share that with you guys too. So any questions with the offset? It's pretty straightforward. Like I said, the biggest thing is, you know, in your geometry, how much do you want to go? Now, one thing interesting here is if I tell it to go number of cuts to the right, and if I tell it to go 10 cuts to the right, it won't do that toolpath because I'm actually going off my drive. You know, it'll be pretty much gouging into there. So you'll see, even though that I type it in there, it's not going to do any additional toolpath in there just because it knows that it's going to be hitting that surface right there. So any questions with the offset cutting, guys? Good. All right, so we'll get to the last part here, and we're actually going to be throwing a couple different tool paths on this last part. And radial. Okay, so what we'll do here is I'm going to show you kind of an example of parallel to curve, and it's very, very similar to parallel to curve. There's only one thing I'm having to change around, and so let's just do a parallel to curve first. And our geometry is just going to be our circle here and the radius. And our edge surface that we want to follow is going to be the bottom here. Did it not let me, oh, I did parallel to surface, parallel to curve. Sorry about that, guys. Okay, so we'll come in here and grab our cutter. And let's just see what we have so far here. Okay, so we got some linking. So I think if I just come over here to do spiral, should clean up our, there we go. Now if I switch this over to a 10th step over, oops, sorry, here. Okay, so we're looking good here. We're going to kind of pretty much mimic that tool path. I was thinking we'd have a little bit of a surface deviation up here, but looks like it got it this time. So now what we'll do is do our HSS and do our radial. And our drive surface, the surface that we want to cut. Okay, so now one thing we can do is I can actually change the point. So if I do auto detect the center point, and let me just grab some toolpath here, it's automatically going to find that center for me of that circle. And we'll just set our toolpath parameters. Yeah, that looks good. And you'll see we're kind of doing perpendicular to a surface right here. So pretty similar there. Not much difference of going on there, guys. But definitely, you know, you can use it as a projection also. Now, if you guys wanted to, for some reason, to actually shift that geometry off to the left or right or up, you guys can uncheck the auto detect and we can actually bounce it around. Now, when you do that, you might get a little bit of the sewing machine effect and get some ups and downs there, but you know, if you guys need to, you can definitely do that. Okay, so now if we come in here and do another HSS, guys, we will do a spiral, which should pretty much mimic the parallel to surface, or parallel to curve. So we'll do a drive here. And we'll do our auto detect again. So it's cutting right on the center. And we can go to our, oh, this one's automatically. I'm not going to have to switch it over to spiral. All I get is one option to do clockwise or counterclockwise because we're already doing a projection of spiral there. So let's do a save and calculate. And what do we set? We set a 10th step over. I should fix that real quick. Okay, so you can see we're just doing a nice spiral down, working our way from the center, working our way down, and to kind of match it up with what we were having before is if we set this to 10th out here. Obviously, this can take just a little bit more time to calculate because we went from 50th step over to a 10th. And the also reason why it's taking just a little bit longer too is because we're telling it to kind of project onto a surface. And like I said, we're getting an identical toolpath to HSS parallel to curve, but it's just kind of doing the projection style here. So okay, we should be finishing up here. There we go. So like a nice tight spiral from starting from the top. So now if we kind of compare these, I'll let me kind of minimize this here. I'll try to get zoomed in for you guys. For myself, you know, you can see the actual center point where it's kind of coming in here. If I get a straight down view, for myself, I really can't tell a difference. Looks like we have a little bit tighter spirals at the top versus the other one here, but not a huge amount of difference here. So this one is kind of the one that I've really never used, guys. So, but it looks like we might get a little bit nicer finish on that more top surface versus where we are doing parallel to curve, and it's a little bit more spread out there. So a little bit tighter put together, I guess, but that's all I can really think of with that spiral there. So any questions, guys? Nothing. Now there's something that I came across, actually Greg showed me too, and has nothing to do with SolidCAM at all, but it has to do with your computing speed of your computer. For those of you guys that want, you guys can actually, if you guys go to a website, and I can give you the website, but let me pull it up here. This is the Intel Extreme Tuning. You guys can actually overclock your cores, and that's what I kind of did right here, is overclocked them just a little bit so you can see that I'm running. I'm going into super geek mode here, but my default with turbo is 3.5 hertz, and now I'm up to 3.7. So help you out a little bit with the processing time, but if anybody is curious about that, shoot me an email and I can send you the link for it. It's something that we just kind of came across, and it might help you guys out some bit at all. But any questions, guys, at all with the projection? Like I said, it's something that I don't run across a lot, but definitely it definitely has its benefits, as you can see when we're doing, that user defined, as we're doing that chamfer going around the part there. But looks like either I put you guys to sleep or answered all the questions, or got you guys even more. Go over the geometry again. For the projection, I'm guessing, Ronnie? Okay, so here, there's not much to the geometry. Basically just doing the drive. You guys can select your direction here. I'm not sure why we would ever use X, Y, or Z, or I'm sorry, X or Y here. Let's just try doing Y real quick. It may, oh shoot, what I should have done is change my step over to something a little bit larger. And it may just fail on us also here, but this kind of may lead into more of the 5-axis side of things, is kind of where I'm guessing we're going to be going with this projection stuff with the direction here. But I'm not 100% sure, because like I said, it's just something I don't use very often with programming parts, or when I was programming parts prior to working at SolidCAM. But let me just hit the cancel button. Yeah. Let's see if we can do toolpath parameters. Let's do yeah, so now we're getting, looks like we're only getting half of what we were getting before. Something I'll have to look in for you guys, I guess, for the on the geometry side of things of the Y direction. Looks like it's just doing in the Y plus direction right now, and just doing it that way, kind of doing a spiral down. So I'm guessing if we did just X, it's just going to do it in the X plus direction. Yep. So I guess that direction is just what direction do you want to project onto? So X plus or X negative. That kind of help out there, Ronnie? Okay, yep, perfect. So, and I think this is kind of lead into the 5-axis, because HSS is the same as 5-axis, but yeah. Any other questions, guys? All right, well, if that's it, thanks again for taking the time out of your night to do it. Hopefully you guys learned at least something out of there, got some trick out of there. But like I said, if you guys have those ideas, definitely send those over to me in an email, and we'll get those implemented in. And if you guys just want to, shoot me a part or anything, just send it over to us, and we'll take a peek at it for you. So, Terrence, you got anything else you want to add?
No, you guys have a great holiday weekend coming up.
Oh, that's right. Nice holiday weekend. Perfect. All right, guys. Have a wonderful night, and thanks again for your time, and look forward to talking to you guys next week. All right. Bye, guys.
Take care.